All right, here's our video lesson for graphing polar equations. The things that I want you to have for this lesson, video lesson, are the notes packet, a unit circle, a calculator, and this half sheet that I gave you, which I'll explain more about in a second. So what we have is this packet has our notes on top. We have 2 practice problems that we're going to graph. On the back is a summary of different polar curves, and then you have your second sheet is your practice problems. So I'm just going to look at the notes. This is a bunch of different shapes of polar graphs that we could have depending on the equation form that we're given. So this top section is limicons, which we're going to be focusing on today, but also there's some examples of rose curves, circles, and lemniscots. And I'm not really sure how to pronounce that word. I need to look that up. But for now, we're going with lemniscots. So since we're just focusing on the limicons, I have given you this half sheet in class that has just that part of the table with the limicons and the 4 different shapes of those that we could have. We'll talk about how to know which one you should expect. And then I have the procedure I'm about to do. I have it broken down here in steps for you. So I'm just going to explain the steps and these different shapes in this table as we go through the practice problems. All right, so here's our first practice problem. Our goal here is to graph this polar equation, r equals 3 minus 4 sine theta. And we have a table here to help generate our points. These are the theta values that are going to be my domain that I'm going to plug in here. And then after I do this math, I'll have r values, the r values that coordinate with those. And then we'll graph them over here and finish out our shape. The first step on here that I asked for you to do is to label theta values from the table onto the polar grid. So my negative angles are going to go here. This is negative pi over 2. Remember that negative angles start at this pole and they rotate clockwise this way. So negative pi over 2, negative pi over 3, negative pi over 6, 0, and then positive pi over 6, positive pi over 3, and then pi over 2. Then the second step that I'm going to have you do is identify A and B and the A over B ratio. So now let's take a minute and just look at this table and why we want this information. First thing is that A and B are these values in our equation. A is a constant, B is the coefficient being multiplied by either the cosine or the sine. And when we go to determine the A or B, we are not going to be including the plus or minus in the middle, just strictly A and strictly B. And then we're going to write them as a ratio, A on top and B on bottom. And depending on how that ratio compares to 1 or 2 or themselves, you'll get one of these shapes. So if that ratio is less than 1, you're going to have a limicon with an inner loop. So it creates a loop inside there. If A and B are the same, you'll have a cardioid. There is no loop inside. It just comes to a point and then goes back out. If that A over B ratio is greater than 1 but less than 2, we'll have this shape right here, a limicon with a dimple. So it doesn't quite go in as far as the cardioid did. And then if A over B is greater than or equal to 2, you'll see that that dip in is even less pronounced, and that's called a convex limicon. So that's why we want to figure out what this A over B ratio is so we can know which shape we're expecting to draw from our given points. So in this particular problem that we're looking at, this is my A right here, the 3, and this is my B, the 4. So I'm going to write that as a ratio, A over B. and this is less than 1. So I know that I'm expecting to end up with a shape that is a limicon with an inner loop. So I'm just going to make a note of that here. And then go back to my problem. So the next step I want to do is to calculate the R values and fill in the table and then graph the points. I'm going to do the points from the graph in one color, and then later in the problem I'm going to be using a second color for a different purpose. This is optional. You do not have to be doing that, and I'll explain more about that when I get to it. But here's how we're going to generate our points. So I'm going to take each of these thetas individually and plug it into my equation here for theta. So to find the R value for when theta is -2, I'm going to have 3 minus 4 times whatever sine of -pi/2 is. So there's my 3 minus 4, and then that 4 times sine of -pi/2. So I'm going to go to my unit circle, find -pi/2, which is here, and the sine value there is the y value there, which is -1. So sine of -pi/2 equals -1. So it can replace the sine theta there in my equation. So now I'm going to follow my order of operations, or PEMDAS. Multiplication comes before addition. So I'm going to multiply these first. -4 times -1 is +4. And then add that to this 3, that makes 7. Okay, you can see how if you did this out of order, if you did 3 minus 4 first, you would have -1 times this -1 is not 7. So be sure you're following your order of operations. So to graph this, I'm going to go to my pole that's at -pi/2, and I'm going to count 7 circles from the origin. So 1, 2, 3, 4, 5, 6, 7. Right there. And we are going to do this for the rest of my thetas. The sign at -pi/3 is -rad3/2. Multiplying these two together, adding 3, this is approximately 6.5. So at -pi/3, I'm going to count 6.5 circles. Then I move on to -pi/6, so 3 minus 4 times the sine of -pi/6, which is -1/2. So half of 4 is 2, negative times negative is positive, so +2 plus 3 is 5. Now we'll do 0. 3 minus 4 times the sine of 0 is 0. So 4 times 0 is 0, plus 3 is 3. So on the 0 pole, I'm going to count 3. Now pi/6. So since we're finding the sine values and those are y's, the y value at pi/6 is going to be the opposite sign to whatever -pi/6 was. So it'll be 3 minus 4 times positive rad3/2. Or if you just go to your unit circle at pi/6. Oh wait, what did I do wrong? Oh, I read the wrong thing. Sorry. My bad. It'll be +1/2. Thank you. So half of -4 is -2, plus 3 is 1. So at pi/6, I'm going to count 1 circle. Plug in pi/3 for theta. At pi/3, your sine value, this is the positive rad3/2 that I was trying to get at a minute ago. That's going to give me -0.5. So this is the first one where our r is a negative value. So at pi/3, here's my pi over 3, the pole. To count -5 for an r, I'm going to go backwards this way. And then for pi over 2, the y value is 1. 3 minus 4 is -1. So again, here's my pi over 2 pole, but I need to count backwards this way at 1. And you can see here that I only have half of my limacon. And here's how I'm going to get my other half. Now, you probably noticed here that this is going to end up being symmetrical over this vertical axis right here. So this has a vertical symmetry. So that's good, because instead of creating a whole other table to generate all the other points I need, I'm just going to do it symmetrical over this vertical axis. So this point here at pi over 3 symmetrically goes here is a symmetrical point. This point at pi over 6 reflects to here. This point on the 0 reflects over here. This point at the negative pi over 6 reflects here. And then this one at the negative pi over 3 goes here. So in red, I did the new points that I generated using symmetry. These were not points generated by our original table. So those are all in black. So then I'm just going to complete my shape here. Not very well, but also not the worst. So here's my limacon with a inner loop. And I'm going to make a second video for the second problem.